What we're seeing here is that the reef is changing over time.
Yeah.
We had a huge coral bleaching event in 1998 that was the hottest year in record, and that also affected the Maldives on a grand scale, where up to 90% of all the shallow water coral species, reef-building coral species, died. And they bleached.
Because why?
Because the seawater rose by only about 2-3 degrees. So only that tiny temperature difference can already
killed off the coral.
Killed off the coral, made a huge difference to the reefs. And we're still affected by it because still the corals are only recovering. The reefs luckily are very resilient. So many of the reefs have come back brilliantly. We're now seeing a lot of healthy coral, especially the fast-growing corals who can grow up to 15 centimeters a year. They are producing some great skeletons. So the reefs are coming back, but we just need to give them the proper growing conditions.
You had one warm year, or one year where the waters were very warm.
That was an extreme year. There's always coral bleaching events. It's a natural event. But the El Nino year, 98, just had a huge effect on the reefs in the Maldives.
And such that a temperature rise of how much? 2 or 3 degrees?
2 or 3 degrees out of the normal. And the normal range here is about 28 to 30 degrees. So an additional 2 degrees over an extended time period can have a detrimental effect on the reefs here.
There's a fallout from that, though. What happens if the coral, which is protection for the islands, starts to deteriorate?
The water level above the reef increases. That means also that the waves will have much more energy now and will come crashing towards the beaches, taking away more and more sand, so that potentially erosion problems could follow, so that the islands will get affected more and more by the sand movement.
All right, so let's take this back through the whole process. The water warms up. You had the bad year, that 2 or 3 degree over a sustained period of time difference in water temperature, bleaches the coral, kills it off. What happens then? The coral starts to deteriorate, and talk me through it.
Yeah, so the coral loses all its symbiotic algae. It loses the color, it bleaches. All you have left is the white limestone skeleton.
Yes.
These limestone skeletons then become porous. There's algae, filamentous algae starting to settle on the coral. There's grazing fish and other organisms that are starting to, take the coral down, erode it more and more. So you have a lot of loose coral rubble lying on the seafloor. You have a lot of sand that is produced as well. But this coral rubble does not offer the right substrate for new coral larvae to settle on, and you don't have the source of coral larvae anymore. So even it takes a long time until the reef flourishes
the source
again.
The other plants,
other
which are now
reefs.
dead. Other reefs.
Yeah, other coral animals.
All right. So again, going through the chain, warm water or warmer water than you're used to kills the coral. The coral begins to degenerate and not regenerate.
Yeah, the
exposing the islands to more in the way of sea surge, storm surge, currents, and erosion.
Of course also the biodiversity in the reef is affected. You probably lose a few species as well. Maybe fish stocks decline, so that it will eventually also affect food consumption in the islands here.
All as a result of that warming.
It's not only the temperature rise that is affecting the corals, it's also that the oceans are quite likely to become more acidic. So that means that the water will contain so much dissolved carbonic acid that the reefs dissolve over time, or that the animals, the crustaceans and the corals and mollusks do not have the ability anymore to deposit limestone skeleton, calcium carbonate skeleton.
All right, and again, all of this based on warming, even without the issue of the water level. Just the warming of the water contributes to all of this, or it's more complicated than that?
Yeah, it's actually the increase in carbon emissions. So the increase in carbon emissions leads to the uptake of this carbon in the water as well. So the atmospheric carbon gets absorbed. Gets absorbed in the water.
Does it put the islands at risk? And this country is a country of islands.
Sure, these islands are very low-lying. The highest point is about 2.5 meters, 3 meters above the sea level. So a small change in sea level could affect the islands in a big way. However, the islands are changing over time anyway. There's always been a lot of erosion taking place. At the same time, there's a lot of sand sedimentation again and deposition. So there's a constant flow. The islands keep coming up, and some of them will disappear.
Right.
So in the Maldives,
it's a
somehow,
dynamic environment. They're basically sandbars, I suppose. Whatever the islands have been moving, they've been moving in a dynamic little dance along with the reefs, which have provided protection for them. If the reefs are at risk, are the islands more at risk?
They are more at risk as well. If the reefs are not healthy anymore, they can't sustainably produce more sand, so eventually you will end up with less and less sand around the beaches of the islands.
And less islands.
More and more erosions, and then this way the Maldives could be under threat.
Right. So the general view around the world, and that's also been propagated here, that the real threat to the Maldives is rising sea level because they're so low. In fact, there are other changes which are threatening them as well.
It's not really just the sea level rise. Nobody knows what will happen in the next decades. But carbon emissions absorbed in the seawater, they could actually have a big impact. If the oceans become too acidic, really the animals would not be able to produce calcium carbonate skeletons anymore, and that could have a huge impact on the reef complexity, on the whole ecosystem.
So enjoy it now.
Enjoy it while you can.